Hello, welcome to Rosie's Fun Classroom. In today's video, we'll be looking at prime factorization. In our previous video, we looked at prime numbers. We were able to identify prime numbers and differentiate them from composite numbers. And today, we'll be looking at prime factorization. What are prime numbers? Prime numbers are natural numbers which are greater than 1 that have only two factors, 1 and itself. That is to say, if I say that 2 is a prime number, it means that 2 has only two factors, which is 1 and itself. Now, we'll move over to factors. What are factors of a given number? Factors of a given number are numbers that can be multiplied together to get that given number. For instance, what are the factors of 2? Factors of 2 are 1 and 2. 1 times 2 gives us 2. So fact 2 and 1 are factors of 2. Factors of 9. 1 times 9 gives us 9. So 1 is a factor of 9. 3 times 3 gives us 9. So 3 is also a factor of 9. 9 times 1 gives us 9. So 9 is also a factor of 9. So the factors of 9 are 1, 3, and 9. Moving over to prime factors. What are prime factors of a given number? Prime factors of a given number are factors of that number that are prime numbers. Now, what are the prime factors of 10? First, we'll find the factors of 10. What are the factors of 10? Factors of 10. 1 times 10 gives us 10. 2 times 5 gives us 10. 5 times 2 gives us 10. 10 times 1 gives us 10. That is to say, the factors of 10 are 1, 2, 5, and 10. So, what are the prime factors of 10? The prime factors of 10 are those factors of 10 that are prime numbers in 1, 2, 5, and 10. What are those numbers, those factors that are prime numbers? 1 is neither a composite number nor a prime number. So 1 is not a prime factor. 2 is a prime factor because it has only two factors, 1 and itself. 5 rather, it's a prime factor because it has only two factors, 1 and itself. 10 is a composite number because it has more than two factors. Now, the prime factors of 10 are 2 and 5. Prime factorization is a process of finding prime factors of a given number. Now, we're going to look at some examples of prime factorization. Prime factorization can be got in two methods. The first method is called the factor tree method, while the second method is called the continuous division method. Now, I'm going to show you the workboard where we're going to do some worked examples on finding prime factors. That is prime factorization. See you there. Example 1 says, find the prime factors of 60. What are the prime factors of 60? Now, using the factor tree method, we are going to find the factors of 60. 60 is an even number, so we use the smallest even number. 2 into 6 gives us 3. 2 into 0 gives us 0. 30, an even number, so we use 2, the smallest even number. 2 into 30 gives us 1, remain the 1. 2 into 10 gives us 5. 15 is an odd number. So we use the smallest odd number, which is 3. 3 into 15 gives us 5. 5 into itself gives us 1. So, what are the factors, the prime factors of 60? Now, the factors of 60 are 2, 3, 2, 2, 3, and 5. Remember, 2 times 2 gives us 4. 4 times 3 gives us 12. 12 times 5 gives us 60. So, what are the prime factors of 60? What are those numbers that are prime numbers? Those factors that are prime numbers in the factors of 60. Now, the prime numbers are 2, 3, and 5. These are the prime factors of 60. Now, moving over to the continuous division method, we say 60, 2, 2 into 6, 3, 2 into 0, 0, 2 into 3, 1, 2 into 10, 5, 3 into 15, 5, 5 into itself, 1. So, factors 60 is equal to 2 times 2 times 3 times 5. Now, what are those numbers that are prime numbers and are also factors of 60? 60 is equal to 2, 3, 2 is a prime factor, is a prime number, 3 is a prime number, and 5 is the prime number. So 2, 3, and 5. Now, if you're asked to express 60 as a product of its prime, this is what you're going to do. This is what you're going to do. 2 times 2 times 3 times 5. But if you're asked to find the prime factors of 60, you say 2, 3, and 5. Now, we are going to look at a past question in common entrance. Express 90 as a product of its prime numbers. Now, going over to 90, 2 into 9 gives us 4, remainder 1. 2 into 10 gives us 5. 45 is an odd number, so we use 3, the smallest odd number. 3 into 4 gives us 1, remainder 1. 3 into 15 gives us 5. Now, we use 3 as the smallest odd number. 3 into 15 gives us 5. 5 into itself gives us 1. So, we want to express 90 as a product of its prime numbers. What are? So, 90, we have 2 times 3 times 3 times 5. So, using the index form, 2 is raised to power 1 times 3 raised to power 2 times 5. We have expressed 90 as a product of its prime. Remember, if you're just asked to find the prime factors of 90, you're going to say prime factors equal to 2, 3, and 5. Okay, let's go to using the continuous division method. 90. 2 into 9 gives us 4. Remember 1. 2 into 10 gives us 5. Now, 45 is an odd number, so we use 3, the smallest odd number. 3 into 4 gives us 1. Remember 1. 3 into 15 gives us 5. We still use 3 because this is an odd number. We use the smallest odd number. 3 into 15 gives us 5. 5 is an odd number. We use 5 because it goes into itself. 5 into itself gives us 1. So 90 is equal to 2 times 3 times 3 times 5. Prime factors of 90 is equal to 2, 3, and 5. I hope you understood what we just explained, what I just explained using the two methods. Now, we are not to be stereotyped in our learning. Any method that is most convenient for you can be used to answer your questions. Now, if you understood this and you know this was explained in the simplest methods, please look for the factors, prime factors of 45. Find the prime factors of 45. The first person to get an answer, to get the answer in the comment section, gets a reward from me. See you in my next video. Bye-bye.